Hey, welcome back to ZwitterCo Unfiltered, real talk on membranes for food, dairy, biotech, fermentation processing. I'm Jon Goodman, Vice President, Process and Specialty at ZwitterCo, your host for today's episode. I'm joined by Scott Brown, one of our resident experts and working in North America with our dairy customers. During today's episode, we're going to talk about a couple of questions that we've received from customers, and then our topic for today is going to be element autopsies. So let's start off with customer questions. First one, do I need to make changes to my system to run ZwitterCo elements?
And that's the beauty of the whole thing, is that it's dropped in, just put in and then play it. The fact of the matter is we should never have to change anything. The only thing that we may have to change is we actually may need to take some surface area off because of the way that the ZwitterCo element fluxes. We seem to permeate 50 to 100% more flow than conventional elements. And at times that could necessitate the need to take elements offline.
And that's an interesting point, Scott, because in testing, we've seen, of course, it's highly dependent on the total solids. We've seen 10 to 20% higher operating flux at low solids, where conventional membranes already operate at high flux. And then as the solids go up at high total solids, we've seen the much higher operating flux. I think it'll be interesting to see how much that varies as we get more field data from different from different feed streams.
Field data is coming in now. We're getting more and more of it all the time, and really excited to see all of this and compile it all as it comes in. It's really exciting.
Of course, the other thing is we definitely do work with customers. The one thing that does need to be changed, other than Lily jumping up on the screen, oh, hello, buddy. And we will be joined periodically by some of our friends. So one thing that we definitely do work with customers to change is the cleaning program, because a lot of the benefits, in fact, virtually all the benefits from ZwitterCo membranes come from the anti-fouling nature of the product. And part of that is changing the cleaning program to save money, reduce chemicals, water, wastewater, energy, and most importantly is time. By shortening the cleaning program, we can give customers back time.
And time is the biggest blessing. Anybody who's worked in a dairy plant knows that the things that the upper management always talks about is yield and time. And the more time that we can give you, ultimately, the more yield we'll give you. And again, like Jon said, after I've worked for a major cleaning company for 4 years, and cleaning is a big, important part of every single process that we do. If we look at the cleaning procedure that you have in place, and I can take one of those steps out, give you an hour back, plus the flush water, plus, the chemistry savings, it's a win-win all the way down the road.
Yeah. Excellent. The second question that we get is, do you roll special sized elements? And of course, what counts as a special sized element is kind of interesting. Of course, we are offering all the standard sizes for the industry. We're offering 63 and 64 38s, 80 38s, of course, 38 38s. There are still some smaller operating systems with 38 38s, although a lot of people are using those for R&D.
78 38s.
And that's where we get into, are these special size? 78 38s. We will offer 4.3 inch. And we've gotten requests for 25 38s. So we are going to roll some 25 38s. They fit into the Alpha Laval lab units where there's an extra housing commonly found in biotechnology and fermentation testing. So we'll offer 25 38s. And also for benchtop proof of concept testing, we offer 1812s. And this is the flush-ended full fit style 1812. We also offer a number of different feed spacers from 30 mil up to 80 mil. Of course, with the 80 mil, it isn't available in all element sizes, but for the 6 inch and the 8 inch, we are offering those. So 30, 46, 65, and 80 mil feed spacers are available. Please talk to Scott or myself or Leonid over in Europe with questions on membranes. So our topic today is element autopsies. And, when we were talking about this, we were talking about sharing some of our interesting autopsy experiences. Because with an autopsy, it's more than just a story. But before we get into that, why don't we start with, what is an autopsy and why do we autopsy? Scott, what you want to start that one off? It's interesting because, we don't rehearse this. And so it's always interesting to compare notes.
And from a plant point of view, autopsy is really, really important. And anytime we changed out elements, I would select just a couple of elements and cut them open, just have a look. Of course, we have to do autopsy when USDA shows up, right? Because they want to see, is there blistering? Is there some reason that the elements are holding on to bacteria? Or there's a lot of reasons why we need to do autopsy. I always found it very interesting to cut them open and just have a look at what's going on inside. Not that you can see the membrane itself, but to see what's going on inside of the element. And it's always interesting to see the glue lines. It's always interesting to see, is there product or are there pieces I've seen pieces of gasket material shoved into the feed spacer. I've seen all kinds of crazy stuff, right? I found sand, actual sand inside the element.
Certainly. And it's interesting because, you are talking about it from at the user site.
Yeah.
USDA. And I've spent my whole career working for membrane companies as a supplier. And so there's two general reasons for autopsies that a membrane company performs. One is in manufacturing. There's proactive autopsies, and operations does this all the time. And they're doing that to check the designs, to check glue lines, to check active area. Are the leaves being inserted properly? Sometimes it's used for training of operators to improve quality, but generally it is in manufacturing to confirm designs and then, of course, get into troubleshooting. And that's where I'm most familiar with autopsies is failure analysis. And I've always had a good time with that. I've been fortunate enough to be located at the production facility at the site. And so generally I did my own autopsies for failure analysis. Similar to what you were saying before, Scott, about what you're looking for. It is called an autopsy. So I guess it is similar in a way to a medical procedure where you're trying to solve a mystery. We often ask for data in failure analysis from a customer because we're trying to understand, okay, what did the customer see? Did they see high passage? Did they see low flux? Did they see some other problem in their system? And then we get an element back and we cut it open and we look for things. And what we're trying to do is, can we solve that mystery of why the system is operating the way it is? You mentioned earlier some of the things you look at. You mentioned glue lines. What else are you looking for?
Absolutely. And then personally, I like to roll the whole element open, get a good look at the whole leaf all the way around, clear down to where the permeate carrier goes around the permeate tube. I check along that seam on the inside, looking for anything, primarily looking for product that isn't getting cleaned out properly. Or, and again, 4 years at a cleaning company, it was always the accusation that we weren't getting all of the product out of the element, right? So that would be a good place to look. I would also look for cracks in the membrane itself, right? We would also do what I call a fold test. So I would take the membrane leaf and I would fold it back and forth just to see if I could get it to crack, to see if maybe we had, I don't know, gotten chlorine into an RO mistakenly, or it made that membrane brittle. All these things were things that I've looked at in the past.
It's funny. I think that especially, and this is more true in process applications than in water, but in process applications, in our food processing especially, the most sensitive area is right at the crease where the membrane fold, where the leaves are inserted up to the tube. And as Scott mentioned, does it get clean? That's where, chlorine, as you were saying, makes membrane brittle. And if it's going to fail, it's at the crease. That's why membrane companies put crease protection in. And so we're looking for, is it clean? Is it cracking? Are there any wrinkles? Was the feed spacer inserted properly? We're always looking at the fold. And one of my stories, and this will go back to the 1990s, there were systems that were undersized and they would do a midday wash. And some of the washes were getting more and more aggressive. And I got some elements back and the customer had said that they lost rejection. It was a catastrophic failure. Get these elements back, open it up, and the crease actually had split open. And it was like, what the heck is going on? If the first set, give a warranty, it's like, oh, it must have been a defect. Come back from another customer where the system had been built by the same company. And sure enough, it's the same issue. And what did we find? They were doing midday washes that had the alkaline, the high pH weakens the polyester that the membrane is cast on. And the weakest spot in the polyester is where the membrane's folded.
It just stands to reason.
Yeah, where it's creased. And then we found that the soft starts weren't working. So what was happening was the polyester was getting degraded and weakened, and the soft starts weren't working. So when that system would start, there would just be this hammer, and it actually was enough to tear the membrane. And as a result, when I would do autopsies, I would do exactly what you're saying, Scott. I'd go down to the tube, pull the membrane out, and I would just try to put my finger through the membrane.
Yeah.
And if I could put my finger through the membrane, it was really evidence that they were overcleaning the membranes. And for a while there, that became a standard part of the test. It's not real scientific, I'll admit.
I mean, it worked, right? And you knew that it was consistent.
The other thing that if you think that there may be too much cleaning, overcleaning, because of this polyester degrading, I could take the membrane and turn it over and rub my hand just in circles on the back side of the membrane, and polyester fibers would start coming up.
I've never seen that.
You haven't seen that? It was very effective. I started doing autopsies very regularly in conference rooms or on production floors, and I would just do these things and tear out a leaf and try putting my finger through it and rub the back of it. I haven't seen this in a while. This was a 1990s thing, I think. I was also taught by a very wise man that there's no substitute for membrane area. Starting probably 20 years ago, there seemed to be more membrane area being put into systems operating at more conservative fluxes. And I think everyone's seen that you get better overall performance that way.
Well, and here's the thing too, Jon, and I know you've seen this as well. After working for an OEM for 6 years, we discovered that no matter how much extra surface area we put on the system, the customer is going to end up running it to 112%.
Always.
I mean, that's it without fail.
Yeah. And it all comes down to when the system is put in, what the volume it's designed for. But I've really never known a customer who doesn't want to process more.
Right. When I was running the plant, I was always trying to cheat the system, right? Trying to figure out a way to get more product through whichever system it was that we were working on today.
I was thinking of other things I've found in membrane. You're mentioning sand.
Yeah.
How about an insect that was actually cast into the membrane? I opened an element and there was a fly that obviously had gotten in during membrane production and was actually cast in the membrane. Open up the element, and I said nothing. I mean, actually, I can't remember what the reason for the autopsy. It probably was high salt passage. It was an RO membrane. Open up the thing, and can you imagine? In the middle of the leaf, there's actually an insect in the element.
Can you imagine the odds of finding a bug cast into the membrane just from cutting one element open and finding that one leaf? That's after you should have been out and bought a lottery ticket that day.
Yeah, well, maybe the insect should have, but but that's one of those things when autopsying. I mean, when doing failure analysis, we look at every leaf. We're looking for oddities, because when you have an element back, you don't know where the defect is. So generally, you're looking at every leaf. And another thing that is very common that we look for are wrinkles.
Sure. Yeah.
Wrinkles sometimes don't have an impact. We'll sometimes refer to them as soft wrinkles, whereas on the other hand, wrinkles oftentimes are bad. And then depending on where the wrinkles are in the leaf, they can be formed for different reasons, whether it's the leaf insertion, the tensioning of the element rolling, back pressure causes wrinkles in leaves. And we get a lot more wrinkles in elements that we see in sanitary elements than in fiberglass water elements. And that is primarily due to the fact that when a sanitary element is made, the element is rolled, the glue is cured, and then that element is opened again so that the leaves can be trimmed, so that there's cut through the back glue lines so that they're sanitary. A vacuum is pulled, of course, when you open up that element again to keep the air out. But a lot of people, I'm sure you've seen it. As soon as you open up an element, if you don't have it under vacuum, the leaves start filling up with air.
Oh, yeah.
So if you try then pulling that element tight again, which of course you do it when making a sanitary element, if you don't get all the air out, you're going to get a wrinkle. And it's a killer from a manufacturing standpoint. That was another one of those things that membrane companies learned back in the 1980s and early 1990s when we were just making full fits, initially smaller 3.8 inch and 4.3 inch. And then as we went to larger sizes, more vacuum was needed to pull that air out.
Sure.
And so all those things were learned. What other stories have you got from an autopsy?
Like I said, the sand was a big deal, right? We were getting a lot of passage. The elements were old, though. I mean, the elements were like 3 years old. They should have been changed. I found all kinds of stuff caked in there. The fine saver quit working and just packed that element full.
That's one of the stories that I have was I actually once went, customer had me come to Europe to visit a site. It was interesting because the weight plant was owned by one company and the cheese plant were from a different company, and they were co-located. And so it's different sides of the building, of course. And so there was a disagreement on what the cause of this membrane failure was. So I went to Europe as the supplier of the membranes to be the neutral arbiter. And it was so funny. I mean, we pick up this element. I mean, I don't know how heavy it was. It was a heck of a lot heavier than it should have been.
Right.
But you could just look at it and see. I mean, I knew immediately from looking at it what the problem was. So I didn't want to take this thing anywhere. We just did it right on the floor. And it's just like, give me a knife. We cut it open. It was loaded with cheese fines.
Yeah.
And it's like, come on, guys. If the element weighs, a wet 8-inch membrane should weigh somewhere in the neighborhood of, 35 to 40 pounds, less than 20 kilos. If you have an element that's 50 or 60 pounds, 25, 30 kilos, it's loaded, whether it's with cheese fines or sand, or, it could be scale and a water element if it's not organic solids.
Yeah. Or fat,
Yeah.
The separators aren't working correctly, right? And they're sending, the rule of thumb for me in the plant was 0.08 on the fat, right? Feeding my RO. And if I got anything higher than that, I went up and talked to the guy that was operating the separators and the clarifiers, right? And if I got anything above the 0.0, and you get a 0.15, 0.18, now all of a sudden the thing's just slammed with fat, right? It plugs up and you're done.
Yep. And those are some interesting applications, of course, if you got fat for ZwitterCo membranes.
But that was back in the day. Again, like you were talking about, the late 90s or early 2000s, right? So,
well, very good. We've been going on about autopsies. I want to make an offer to any listener, because we do run into customers periodically who aren't familiar with autopsies or haven't seen an element autopsy. Scott or I will be glad to come visit your plant and do an autopsy and walk you through it and tell you what we see and provide that service.
So, and hopefully you won't find a fly.
And well, as long as it's our membrane, we definitely don't want to find a fly. Please feel free to share any stories that you have of what you've seen in autopsies, whether it's during a USDA visit or on your own, or troubleshooting. Please send questions, and we'll be glad to share feedback and questions on a future episode. Thanks very much for listening. I'm Jon.
And I'm Scott. And you guys have a great day.